Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on temporary total hardness in terms of calcium carbonate equivalent by using EDTA method. So here a sample water of 20 ml. So how the sample water it contains 20 ml required 18.2 ml of 0.01 m EDTA solution. So a sample water of 20 ml. So simply it says 20 ml of hot water sample required 18.2 ml of EDTA. So that EDTA molarity is 0.01 m. 0.01 m EDTA solution with EBT indicator. EBT as indicator. So already we know that previous classes we discussed what is EDTA method, what is the procedure of EDTA. So generally EDTA acts as a complexing agent. So what purpose we are using EDTA? EDTA abbreviation is ethylene diamine tetraesteric acid. This EDTA mainly used for determination of hardness or estimation of hardness by using EDTA. So EDTA acts as a complexing agent. It forms complex with hardness causing ions which are present in water. So what is the hardness causing ions present in water? Calcium, magnesium ions of bicarbonates, chlorides, sulfates which are present in water. So this how much amount of these hardness causing ions present in that given water, it can be easily estimated by using EDTA solution. So in this case EDTA acts as a complexing agent, and here we are using indicator is aerochrome black tea, EBT, aerochrome black tea indicator. For example, what is the procedure? Given water sample taken in conical, this is a conical flask. So given water sample taken in conical flask and we are adding buffer and EBT indicator. So what purpose we are using buffer? To maintain stable pH. So in this method we are using pH, we are maintaining pH ranges 8 to 10. So at this pH range only EDTA forms complex with hardness causing ions. So in the conical flask we are taking given hot water sample and buffer and aerochrome black tea indicator. So here EBT used as an indicator. What purpose we are adding indicator? To identification of endpoint. So when we are adding EBT indicator, the color of the solution is wine red. This is the wine red color. So the color of the solution is wine red. So after titration with EDTA, so then color changes to blue. The color changes to blue. So wine red color changes to blue color. That is the end point. So coming to this problem or data, a sample of water 20 ml required. 20 ml hot water sample, it required 18.2 ml of EDTA. So what is the molarity of this EDTA? Given this 0.01 m EDTA solution. And with EBT as indicator, and it's and one more case is 4.6 ml of 0.01 m EDTA. So in second case, the molarity of EDTA is 0.01 and it is required EDTA is 4.6 ml. So for the same volume of water means 20 ml only. In first case we are taking 20 ml, second case also we are taking 20 ml. But it requires EDTA is 4.6 because here after removing the carbonate hardness, that meaning we can remove temporary hardness of water or temporary causing ions. So how can we remove temporary hardness causing ions? By boiling. So during boiling process, the dissolved calcium or magnesium bicarbonate is converted into soluble precipitates like calcium carbonate or magnesium hydroxide. Insoluble precipitates are formed. So the same quantity of water, it's required 4.6 ml of EDTA and molarity of that EDTA is 0.01. But in this case, we can remove the temporary hardness causing ions by boiling. So now calculate the total permanent hardness in terms of CaCO3, calcium carbonate equivalent. Why we are converting all the hardness causing salts in CaCO3 equivalent? So already we discussed previous sessions. So calcium carbonate is highly insoluble in water and its molecular weight is 100, equivalent weight is 50. So it makes calculation is very easy. So that's why all the hardness causing ions which are present in water, so all are converted into calcium carbonate equivalent. So here 20 ml of hard water sample, given water sample 20 ml quantity of water volume. So it's required 18.2 ml of EDTA, 18.2 ml of EDTA, and the molarity of EDTA is 0.01 m, 0.01 m EDTA solution with EBT as indicator. Here we are using indicator is EBT indicator, Aeronautical black tea. For what purpose we are adding this indicator? Easily identify the end point. So here 20 ml required 18.2 ml of 0.01 m EDTA solution with EBT as indicator. This is the first case. We can determine the total hardness of water. In second case, we can remove the temporary hardness causing ions which are present in water by boiling process. Generally, temporary hardness causing ions are calcium, magnesium, bicarbonates. So these are you can remove by boiling. So say second case also same volume, that means 20 ml of same after removing temporary hardness causing ions, the 20 ml of the remaining permanent hard water sample taken, and here it's required 4.6 ml of EDTA and the molarity of EDTA is 0.01 m EDTA. So here 4.6 ml of 0.01 m EDTA for the same volume of water after removing the carbonate hardness. So that means we can remove temporary hardness. So in the second case, we can we have to find out we can calculate the permanent hardness of water. Permanent hardness of water. So now we can calculate the molarity of given water sample, given hard water. So what is the formula we are using here? M2V2 equal M3V3 or M3V3 equal M2V2 dash. So here M3V3 related to hard water. M3V3 related to hard water and M2V2 related to EDTA. So that meaning M3 is the molarity of given hard water. So here we don't know that value, we have to find out, so put the question mark. M3 equal molarity of hard water, we have to find out that one, so put the question mark. And next V3 is the volume of hard water. So already we know that the volume of hard water is 20 ml. So here we are writing 20 ml. And next M2. M2 is the molarity of EDTA. Already given here, molarity of EDTA is 0.01. So it's equal 0.01 m. Molarity of EDTA. And next V2. V2 is the volume of EDTA consumed. So in first case, how much ml of EDTA required? 18.2 ml. So V2 equal volume of EDTA consumed, it's equal 18.2 ml. So now we can substitute all the values in this formula. So here we have to find out the M3. So M3 equal, what is the formula? M2V2 by V3 or M2V2 dash by V3. So here M2 means molarity of EDTA, that's value is 0.01. We can substitute here 0.01 and V2 is the volume of EDTA, here 18.2 given in the data. So we can substitute here. And volume of hard water is 20 ml. So M3 is molarity of given hard water, it's equal 18.2 into 0.01 by 20, it's equal 0.0091 molarity, 0.0091 m. So molarity of hard water is 0.0091 m. Then we can calculate the total hardness of water. So total hardness means is present temporary hardness causing ions and permanent hardness causing ions. So temporary hardness causing ions means calcium, magnesium bicarbonates. Permanent hardness causing ions means calcium, magnesium ions of chlorides, sulfates, etc. So now you can calculate the total hardness of water. So what is the formula we are using here? Total hardness equal M3 into 100 into 1000. So here M3 is the molarity of given hot water. M3 is molarity of given hot water into 100. 100 is the molecular weight of calcium carbonate. Molecular weight of calcium carbonate, because hardness is converted into calcium carbonate equivalent. So M3 into 100 into 1000. 1000 means here total makeup solution is 1 liter. So this is the formula used for the determination of total hardness of given water. So we can substitute here in this formula M3 value. M3 is the molarity of given hard water is 0.0091. We can substitute it here 0.0091 into 100 is the calcium carbonate molecular weight and 1000 is the total makeup solution. So it's equal 910 ppm. So total hardness of given water sample is 910 ppm. So now I can calculate the permanent hardness of given water. So here, second case, we can determine the permanent hardness. Permanent hardness of water. So here permanent, how can we calculate the permanent hardness of water? First, we can remove the temporary hardness of water, temporary hardness causing ions. So how can we remove temporary hardness causing ions? By boiling. So during boiling process, this calcium, magnesium bicarbonates are converted into insoluble precipitate. After filtration, we can remove temporary hardness causing ions which are present in water. So here 4.6 ml of 0.01 m EDTA are required for 20 ml of same water sample for determination of permanent hardness of water. So here, what is the formula using here? M4V4 equal M2V2. So M4 means molarity of hard water. We have to find out. So put the question mark. We can find out that one. And next M2 is the molarity of EDTA. M2 is molarity of EDTA. So what is the molarity of EDTA? 0.01 given in the data. So we can write here 0.01 m. And next V4 is the volume of hard water. Volume of hard water, it's equal 20 ml. And next V2 is the volume of EDTA consumed. Volume of EDTA consumed. So here 4.6 ml of EDTA required. So here V2 equal 4.6 ml. So all the values we can substitute in this formula. So what is the formula? M4 equal M2V2 by V4. M4 equal M2V2 by V4. So M4 means molarity of permanent hard water. Molarity of permanent hard water. So it's equal M2. Molarity of EDTA, it's equal 0.01 into V2. V2 is the volume of EDTA consumed. So here you can substitute here 4.6 by V4. V4 is the volume of hard water. It's equal 20 ml. So we can substitute all the values in this formula. M4 equal M2V2 by V4. So it's equal 0.01 into 4.6 by 20. So after calculation, you'll get M4 value is 0.0023 molarity. So capital M we should write here. So molarity of permanent hard water is equal 0.0023 molarity. So permanent hardness. Now here we can calculate the molarity of permanent hard water. Now we can calculate the permanent hardness of given water. So permanent hardness is equal, formula is permanent hardness. It's equal M4 into 100 into 1000. It's equal dash ppm. So permanent hardness, it's equal M4 means molarity of permanent hard water is 0.0023 into 100 is the molecular weight of calcium carbonate and into 1000 total makeup solution is 1000. So after calculation you'll get permanent hardness of given water is 230 ppm. 230 ppm. So now we can calculate the temporary hardness of the water sample. Temporary hardness of water sample. So it's equal total hardness minus permanent hardness. Total hardness minus permanent hardness. So total hardness of given water is 910. Direct value already calculated before that. Total hardness of water is 910. So total hardness is 910 minus permanent hardness of given water sample is 230 ppm. So 910 minus 230 equal to 680 ppm. So permanent hardness of given water sample is 680 ppm. So here total hardness of given water is 910 ppm and permanent hardness of given water is 230 ppm and temporary hardness of given water is 680 ppm. ppm means units of water, it's parts per million. So temporary hardness of given water is 680 ppm. Next one more problem discussed based on that EDTA. So 0.28 grams of calcium carbonate was dissolved in HCl and the solution was made up to 1 liter with distilled water. So what is the meaning here? How can you prepare 1 liter of hard water sample? So here we are taking 0.28 grams of calcium carbonate dissolved in few drops of HCl. Then total make up 1000 ml solution or 1 liter of solution by adding distilled water. So next 100 ml of the above solution. So total makeup solution is 1000 ml. In that we have to take 100 ml of above solution. And it's required 28 ml of EDTA. It's 100 ml of water sample, above prepared water sample required 28 ml of EDTA solution on titration. So now 100 ml of hard water sample, it's required in second case. In first case, it's required 20 ml of EDTA solution. So in that case, we have to find out the total hardness of water. In second case, 100 ml of hard water sample required 33 ml of same EDTA solution. So in second case means we can remove the temporary hardness consoles here. So 100 ml of hot water sample requires 33 ml of same EDTA solution on titration. So in third case 100 ml of this water after boiling. Sorry, here in third step we can determine the permanent hardness of water. That means we can remove the temporary hardness of water. So here 100 ml of this water after boiling, cooling and filtering, it's required 10 ml of EDTA solution. It's required 10 ml of EDTA solution on titration. So calculate the temporary and permanent hardness of water sample. So here given 1000 ml of standard hard water contains how many grams of calcium carbonate? 0.28 grams of calcium carbonate. So that means 1000 ml of standard hard water contains, it's equal 0.28 into 1000 milligrams of calcium carbonate. So here 1000 ml of standard hard water contains how many milligrams of calcium carbonate? 280 milligrams of calcium carbonate. So therefore 1 ml of hard water is equal 0.28 milligrams of calcium carbonate. So 20 ml of EDTA is equal 100 ml of standard hard water. So it's equal 100 into 0.28 milligrams of calcium carbonate. So it's equal 100 into 0.28 into 28. So therefore 1 ml of EDTA equal 1 milligrams of calcium carbonate. So now you can calculate the total hardness of water. So 100 ml of hot water it's equal, it requires 33 ml of EDTA. given in the data. 100 ml of hot water sample requires 33 ml of EDTA. So it's equal how many milligrams of calcium carbonate required? 100 ml of hot water, that means 33 into 1 milligram per milligram of calcium carbonate. So it's equal 33 milligrams of calcium carbonate. So therefore 1000 ml of hot water, 1000 ml of hot water, it's equal, you can write here 33 into 1000 by 100. So total hardness of given water, it's equal 330 milligrams per liter or 330 ppm. So now calculate the permanent hardness, NCH, that means non-bicarbonates. That means we can remove temporary hardness causing ions which are present in that given water. So how can we calculate the permanent hardness of water? So here 100 ml of the same water after boiling, cooling, filtering. That means we can remove temporary hardness by boiling. So it's required how much ml of EDTA? 10 ml of EDTA. So it's equal 10 into 1 milligram of CaCO3. So it's equal 10 milligram of CaCO3. So 100 ml of the same water after removing temporary hardness, it's required 10 milligrams of calcium carbonate. So therefore 1000 ml of water, it's equal 10 into 1000 into 100, it's equal 100 milligrams per liter and 100 ppm. So permanent hardness of given water is 100 ppm. So now I can calculate the temporary hardness of water. So how can we calculate temporary hardness of given water? So temporary hardness equal total hardness minus permanent hardness. So total hardness of given water is 330 milligrams per liter. So we can write here total hardness is 330 minus permanent hardness of given water is 100. So 330 minus 100 is equal temporary hardness of given water is 230 milligrams per liter or 230 ppm, because mathematically 1 ppm equal 1 milligram per liter. So mathematically both are equal. So temporary hardness of given water is 230 milligrams per liter equal or 230 ppm. So one more problem we'll discuss based on the EDTA method. So here in an estimation of hardness of water by EDTA titration. So 250 ml of sample of water required 15 ml of 0.025 m EDTA solution. So to get the end point, so calculate the hardness of water. So simple problem here. Estimation of hardness of water by EDTA. Already we know that hardness is estimated by using EDTA. So here 250 ml of sample of water required. So simply it says 250 ml of water required 15 ml of EDTA. So its molarity of the EDTA solution is 0.025 m. 0.025 m EDTA. So now calculate the hardness of water. So what is the solution? So we know that 1 ml of 1 molarity of EDTA generally. 1 ml of 1 molarity of EDTA is equal 100 milligrams of calcium carbonate. 100 milligrams of calcium carbonate. So 1 ml of 0.01 m EDTA equal 1 milligram of calcium carbonate. So therefore 1 ml of 0.025 molarity of EDTA required how many milligrams of calcium carbonate equivalent? So it's equal 2.5 milligrams of calcium carbonate equivalent. So now I can calculate the total hardness of given water sample. So here water sample volume is 250 ml. So 250 ml of a sample water required, it's equal 15 ml of 0.025 m EDTA. So simply we say that volume of water sample is 250 ml and that purpose it required EDTA is 15 ml. And it's equal how many milligrams of calcium carbonate? So 2.5 into 15, it's equal 37.5 milligrams of calcium carbonate equivalent. So therefore 1000 ml of sample of water required. 1000 ml of sample of water required. It's equal 37.5 into 1000 by 250. 37.5 into 1000 by total volume of water sample is 250. So it's equal 150 milligrams of calcium carbonate equivalent. So your total hardness is 150 ppm. This is another way for the determination of total hardness of water by using EDTA method. So last one, based on this EDTA method only. So here 100 ml of water sample required, 20 ml of 0.01 m EDTA for the titration with Aeronautical black tea indicator. Aeronautical black tea indicator. So your volume of the water is 100 ml and its required EDTA volume is 20 ml and the molarity of EDTA solution is 0.01 m EDTA. And here we are using indicator is Aeronautical black tea indicator. So in this EDTA or complexometric titration purpose, we are using indicator is Aeronautical black tea. So when we are adding indicator in this water sample, the color of the solution is wine red. So after titration with EDTA, the color of the solution is blue color. So when wine red color changes to blue color, that is the end point. So that is the volume of EDTA required for that water sample. Okay. So here in second case, 100 ml of the same water sample after boiling. That means we can remove temporary hardness of water. So after boiling and filtering required, here how much ml of EDTA? 10 ml. So here the molarity of EDTA is 0.01 m. So now calculate the total hardness of water or total carbonate and non-carbonate of the sample. That means you can calculate the total hardness of water and permanent and temporary hardness of given water sample. So here solution is, we know that already. Here 1 ml of 1 molarity of EDTA, it's equal 100 milligrams of calcium carbonate. So here 1 ml of 0.01 m EDTA equal 1 milligram of calcium carbonate. So total hardness of 100 ml of sample water required. Total hardness of 100 ml of sample water required, it's equal 20 ml of 0.01 m EDTA. So 20 into 1, it's equal 20 milligrams of calcium carbonate required. So therefore 1000 ml of sample of water is equivalent to, it's equal 20 into 1000 by 100 milligrams of calcium carbonate. So it's equal 200 milligrams of calcium carbonate equivalent. So your total hardness equal 200 milligrams per liter or 200 ppm. So the total hardness of given sample water is 200 ppm or 200 milligrams per liter. So now you can calculate the non-carbonate hardness. That means we can remove temporary hardness. So here we can calculate the permanent hardness of water. So in that case, 100 ml of the same water sample after boiling, filtering consumes. So that means you can, after boiling, the remaining water is called permanent hardness of water because we can remove temporary hardness. So it's equal, its required EDTA is 10 ml and the molarity of EDTA is 0.01 m. So it's equal 10 into 1 milligrams of calcium carbonate. So 100 ml of the sample water after removing temporary hardness causing ions, it's required 10 milligrams of calcium carbonate. So therefore 1000 ml of sample of water is equal to 10 into 1000 by 100 milligrams. It's equal 100 milligrams of calcium carbonate equivalent. So permanent hardness of the water sample equals 100 ppm. 100 ppm. So the carbonate hardness, that means temporary hardness. So how can we determine the temporary hardness of water? So it's equal total hardness minus permanent hardness. or total hardness minus non-carbonate hardness. So total hardness of given water is 200 and total hardness of permanent water, non-carbonate hardness is 100. So 200 minus 100 is equal 100 ppm. So the carbonate hardness or temporary hardness of given water is 100 ppm. So the total hardness of given water is 200 ppm and permanent hardness of given water is 100 ppm and the temporary hardness of given water is 100 ppm. So in this you have to calculate the total temporary and permanent hardness of water. So in this session we'll learn about how can we calculate the temporary hardness and permanent hardness and total hardness of given water sample by using EDTA and EBT indicators. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.